Oop oop, Graham.
Boom shakalaka, sweet sweet potato.
I never know what Graham's going to say, and each time
I don't know what I'm going to say half the time.
And each time I don't know that I should be amused or horrified or disappointed. It's always a combination of all three.
I'll tell you where boom shakalaka, sweet sweet potato came from.
Yeah.
Whether you want to hear it or not. We have a friend, Levy McLaughlin. You've met Levy, I believe. If you haven't, you should. He's a professor of Japanese religions.
He'll be so pleased that we have name-checked him on today's show.
He will be, yeah. That'll make his day. So he had a friend who was in film school, and his friend put the big project together, the film that they were making for their degree, and they had a screening of it. And it was an experimental film with everything that entails experimental student film. And there was this one character every once in a while they would cut to, and she was gyrating her hips and arms in the street, and she would say, boom shakalaka, sweet sweet potato. And it just stuck in my head ever since then. I have no idea where that comes from, but that's where I heard it. So
I have no words.
yeah.
I don't know how to respond to that.
Now that we've wasted 5 minutes of everyone's life, let's go on to today's show.
Here's an awkward segue. I'm here with Dr. Graham Sanders, a professor at the University of Toronto
That's right.
and of medieval Chinese poetry.
Yes, among other things. I happen to be here with Raywat Deonandan,
Lucky you.
Professor of Epidemiology at U of Ottawa.
I want to ask you many questions today, Graham, many questions. One of them is, when you read a scientific paper, as I'm sure you do,
every night.
do you assume it's true? Do you assume it's valid?
Not anymore.
Oh.
Not anymore. I assume that it's gone through some peer review process, which means it's not complete BS, but I don't always assume that they've proven truth.
Why have you assumed that it's...
Well, because that's how the scientific method works, that you have observations, you make a conclusion based on those observations, your hypothesis, but that doesn't necessarily mean the hypothesis is true.
What's changed for you, though? You said you used to think it was true. But...
I just used to think that if it got into a journal, that it went through enough.
And this is a recent transformation in your mind?
No, ever since I became an academic and saw the referee process from the inside. And I'm not in the sciences, but just realizing how fallible referees are and how fallible the process itself is.
So what proportion of published scientific papers do you think are valid?
Valid, that's a better... So by valid... So setting the truth claim aside, which is a very broad, deep claim to make, you mean valid in that they're using correct methods, the conclusions they draw from the data are adequately supported, and so on.
I'm here with a linguistics professor, a language professor, so I have to be very specific in the words that I choose. In the sciences, the words valid and reliable mean very specific things.
Right.
So reliable means, are the results reproducible?
Reproducible, okay.
And validity means, do the results represent the real world?
Okay. So now you're asking the second one.
I don't know what I'm asking.
Okay.
I think I'm asking both.
I heard a statistic out there that it was, or I read or something, I forget where it was, maybe something you sent me. So I can't answer this question innocently.
Gotcha.
That said half of studies are invalid. Well, this is what we have to explore, which it sounds rather high to me.
So let's go back to reliability and validity for a second now. Again, questions I always ask my students, just as an intellectual exercise. Is it possible for a study to be reliable yet not valid?
So that can be reproduced? Yeah, I would think so.
Absolutely.
Sure.
It means you're making the same error over and over again.
Yeah.
Is it possible for a study to be valid but not reliable?
I see. It's possible.
Is it?
I suppose it's possible in that the study captured something that is valid, but in your write-up of the study, you didn't include enough information for people to reproduce that.
That's nuanced. That's a nuanced approach. So taking away
Less likely
errors in writing,
right.
The idea is no. And in a pure intellectual world, anything that's valid necessarily must be reproducible. Unless you're in some strange...
How else do you know if it's valid, though? If you can't reproduce it, then how do you measure its validity anyway?
Well, yeah, exactly. So you have to have different perspectives on the phenomenon to show that, in fact, this probably...
This is actually, remind me, this is perfect for the celestial emporium of benevolent knowledge, this idea of validity. So I've got something for that.
The study that Graham references is the one that I sent him earlier
Yes.
today. It's a famous study, and it's called...
You prepped the witness. It's illegal in Canada.
It's called Why Most Published Research Findings Are False by John P. Ioannidis, if I'm pronouncing that correctly, in PLOS One. And when this came out in 2005, it was groundbreaking. It sort of led to another study about how most half, if not more than half, of psychological studies weren't reproducible. And this has led to all kinds of people dismissing psychology as a fake science, which I do as well, jokingly towards my psychology colleagues.
Right. Did someone publish a paper, Why All Papers by John Pliny Beats Are Invalid? I mean, if you're going around saying that your scientific studies are invalid, what does that say about your study?
But let me ask you a question now. Why do you think that so many of them are not valid?
Now, are we talking about psychology?
No, not anymore. So let's leave psychology aside. Let's not pick on psychology.
What was his purview?
I'll get there in a second. Okay. He was more of a statistical philosopher. He approaches it from mental gymnastics viewpoint.
Right, but now, I mean, in terms of his catchment for studies, was he looking at hard sciences, soft sciences,
mostly hard sciences.
Okay.
Now there's a parallel studies that looked at just drug discovery studies. Right. So I think people at Bayer, the drug company, reanalyzed a bunch of really high-profile drug discovery clinical trials studies and show that half of them are not reproducible, are not reliable, therefore are likely not valid. Why do you think they're not reproducible?
There are a number of answers. One would be that the data itself is false, that they're making these studies up, which happens quite often, apparently. And the other one is, so in other words, they've somehow fudged the data to make it better. And so that's why it can't be reproduced without fudging it. The second one would be the way they wrote up the study left out some key aspect of the experiment.
Right. People always assume it's the second part. It's this inability or this incompleteness in describing the methodology that prevents us from reproducing it. Sometimes that's called the wallpaper effect, as in, well, the wallpaper changed color, so that clearly must have been the issue that, you know.
You know what Oscar Wilde's last words apparently were? Either that wallpaper goes or I do.
I had a friend back when I was a graduate student at the University of Toronto studying physics and neuroscience, and my friend was a PhD student in physics. Back then, Pons and Fleischmann produced their very famous paper on cold fusion.
And margarine.
There you go.
Or skin cream. Sorry.
People, do you see what I'm dealing with here?
It's a margarine. It's a skin cream. No, it's a margarine and a skin cream. It's Pons Fleischmann.
I can't believe it's not science.
It's not.
So Pons and Fleischmann, they had a very famous study that changed the world back in the 80s/90s, and they claimed to have discovered cold fusion. Remember?
I remember this.
The kids these days have no idea what we're talking about.
And I remember immediately thinking that's impossible on its face. You can't create energy out of nothing. But anyway.
Well, it wasn't out of nothing. What they're showing was that if you force these molecules through a lattice, it forces them to combine, and the energy of fusion was released. So it's kind of nuclear fusion that's in a petri dish, essentially. So it's theoretically possible, according to some obscure theories.
Right.
But they claimed they were able to do it. Now, the world went crazy, of course, because if this was true, it means that we have
solve all our problems.
All our problems are solved. So my friend decided to reproduce the Pons and Fleischmann experiment in the U of T physics lab.
Right.
And of course he failed. And he knew he would.
Yes.
And the Toronto Star came calling and gave an interview with him and asked him, so why do you think you weren't able to reproduce the findings? And knowing full well what he was doing, he said, well, clearly they left something out of the methodology.
Okay. You know? But he knew they were faking it, didn't he?
Not faking is a strong word. He knew that it was probably not good science, but he just wanted to be on the paper. So he said, they're leaving something out. Yeah. Now, I'm not disparaging Pons and Fleischmann at all. I think...
Did anyone ever get down to the bottom of what they observed?
Yeah, I don't know the details, but there's a whole lineage of literature that tries to explain what they saw.
Well, that would be the third explanation. So first is they're fudging the data and it's false already, and that's why you can't reproduce it. The second is they're not complete in describing the methodology. The third would be they're not accurate in their observations, that they're observing something and interpreting it incorrectly. Right. So is that what happened in the Pons Fleischmann? They thought they were seeing
possibly
energy, but they weren't.
Or there's a fourth possibility, and that is statistical anomaly. And statistical anomaly manifests in many ways. Classically, we talk about type 1 and type 2 error. Are you familiar with those terms?
No.
So
I'm sure I make both of them.
Consider a jury trial.
I'm a broad spectrum error person.
You have to understand, dear listener, I'm trying so hard to keep this clean.
Yes.
And every time Graham gives me an opening, I gotta say, no, don't go that way.
Broad spectrum error? Okay.
Yeah, you can see where my mind's going right away. So consider that you are a jury trial.
Okay.
And there's a man who's been accused of murder. And the jury can either determine if he's innocent or guilty.
Right. Have you seen 12 Angry Men?
I have.
That's a great film.
Yes.
Yeah.
And
we should have a film list too.
We should have, There are four possibilities. Either he really is guilty and the jury finds him guilty, or either he really is guilty and the jury finds him innocent, or either he really is innocent and the jury finds him guilty, or either he really is innocent and the jury finds him innocent.
Right.
So the jury is right 2 times, and wrong 2 times.
Right.
Finding an innocent man guilty is a type 1 error.
Okay.
Finding a guilty man innocent is a type 2 error.
All right.
So a type 1 error would be a false positive, a type 2 error would be a false negative.
Okay.
Now, as a society, we have decided that it is more problematic to put an innocent man in jail rather than to let a guilty man go free.
Right.
And we do the same.
Which is why the death penalty is so ridiculous, right?
But we do the same thing in science. So we're more forgiving towards letting an actual effect not be detected than we are for finding an effect falsely.
So you'd rather have false negatives than
That's
false
right.
positives.
Exactly, right? So a real life example of that would be something like, we would rather have a drug that works not be discovered than to have a drug that doesn't work enter the marketplace.
Right, right. The exception for that is medical diagnostic testing. I think you'd rather have a false positive than a false negative, mostly, right?
It depends, right?
Because a false positive would lead to further testing and so forth. If it's false negative,
that's
then
right.
You're not
so
going to
diagnostic testing is a whole different deal.
Yeah.
You're absolutely correct. We should have another show on that because there are other kinds of diagnostic measurements we do for that, not just false positive.
I remember I had a cat once.
You didn't?
I did.
Wow.
My first cat, Chloe was her name, in Montreal, and she was very skinny, and I brought her to the vet for another reason, and the vet said, she looks really too skinny. She may have feline leukemia. We can test her for that. And like an idiot, I said, okay, and I paid for the test and got the results back, and they were negative. And I said, that's good news. If they were positive, what would the treatment be? And she said, we don't have any treatment for feline leukemia.
Yeah, so why do you test?
So I was like, what was the test for except to make you some money? But,
exactly right. So in public health management, we often tell people there's no point having a screening test unless there's something you can do something about it. So getting back to type 1 error, we need a cutoff usually to how much type 1 error we permit.
Right.
The cutoff classically is 5%. If we say the probability that this is a thing that's not actually working is less than 5%, we say that's okay. We let it go. So with enough studies, we can say that with a type 1 error that's of 5%, you're going to get a few of them that get through the filter.
Right.
That's the first kind of statistical anomaly that may be responsible for some of these studies that aren't valid. The second kind involves what's called a Bayesian analysis. And Bayesian statistics is really complicated to explain. I'm not going to do that here. We can do that in another show entirely because Bayesian analysis is fun with game shows.
Right, right.
And we'll do a game show example later on in this
This
show's
is part of
evolution.
like the game theory
A little bit
sort
of that.
stuff.
A little bit of that.
And is it part about capturing things that are fuzzy and not?
No, not exactly.
Okay.
Bayesian analysis is about a little bit of knowledge changes the field, changes
see.
probabilities. So consider this example. Let's say you have, I took this example from a paper that I'll link to on the website later on. Consider you have a field of 100 rocks.
100 rocks.
And one of those rocks has a diamond inside of it. And you're going to try to detect which one has the diamond.
Right.
And you have a device, a metal detector, that can detect diamonds. And it has
So it wouldn't be a metal detector.
It's a diamond detector.
Yeah.
You're fine. Fine, Mr. Literal. And this diamond detector has like a 99% accuracy rate.
Right.
So you put it over one of the rocks and it goes ding, 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 diamond.
Right.
What's the probability that you have a diamond?
I see.
Right. Now, you may say, well, it's pretty damn high because this thing almost never fails.
Right.
Or you can say it's 1 in 100 because there are so many rocks without diamonds.
Right.
So
That would be my
there it
response,
is. And
1 in 100,
that's a Bayesian response, is that it doesn't matter how accurate your device is. The fact is you have a greater chance of finding nothing.
Right.
So if you consider all the papers that are published, this 5% probably a type 1 error, you got a large number that actually have nothing.
Okay.
And so if the scientific method is your metal detector, your diamond detector, it's actually going to fail more than it succeeds. That's the logic pretty much put forth by Ioannidis and his
Well,
friends.
that's the importance of reproducibility then, right?
Yeah.
So we shouldn't actually take any scientific study that's an initial result seriously until it's been reproduced
I agree 1,000%.
several times at least.
1,000% like that's a real thing.
So scientist you are.
So there's a lot of supplements being sold online, for example, that have behind them clinical trials they paid for, and the clinical trials are fine. They're double-blind, placebo-controlled trials, except that unless they are reproducible, then they're not actually
Also,
valid.
studies that do or fail to reproduce something, do they get published, or they're not sexy, right?
Very good point. That's the next point I'm going to make. So there's a thing called publication bias, where a lot of science journals will only publish positive results.
Right.
And so we never learned about the field of 100 or 99 rocks without the diamonds.
Yeah.
We only know about the ones with the diamond.
Right. So,
and that's not typical. And that's really what you need is trying to get at is if you're to consider all of the studies that are done, not just the one that are published.
And what was his test to determine something wasn't valid or wasn't true?
He didn't do that. He's put forth a theoretical framework.
Oh, this isn't an actual statistical analysis going
I don't
back
think
and
so.
looking at studies.
To be honest, I didn't read the paper that thoroughly. Look, we have whiskey, we have limited time. I'm not going to read the actual
how's
papers.
your BS detector working? Pinging right now.
I've got a BS in BS.
I got a PhD.
Whereas the bear study, they actually did go back and reanalyze a bunch of 100.
Bear. I'm imagining a bear right now.
Of course you are.
The bear study.
Because that's what you do. So there you have it. So we have...
Hibernating polar bears.
That's a previous episode.
Oh, okay.
Now, Ioannidis also invented something called the Proteus phenomenon. That's related to what we're talking about. The Proteus phenomenon is the greater tendency for replications to contradict the original findings because of publication bias.
Okay.
And he calls it the Proteus phenomenon because your Greek mythology...
Oh, I thought it was a Star Trek reference.
You're hoping. Proteus is the Greek god who could
change,
yes. Exactly, change their appearance. Yeah. Right. So he argues that in fact, because of publication bias, you have this phenomenon where things tend not to be reproducible. Wikipedia relates this to the winner's bias, I think it's called.
Wikipedia itself is very protean.
I'm not going to bash Wikipedia. Wikipedia is great.
It is great.
The great repository of human knowledge. Thank God for Wikipedia. By the way, I used to have a Wikipedia page. I don't know who made it, but they took it down this past year, and I'm...
Wikipedia took it down, or the person who made it?
The Wikipedia took it down.
Really?
Because I'm not famous enough.
We should marshal our 100 listeners to go rebuild that page.
It used to be fun because I never had nothing to do with it. I just go there occasionally to see who's...
What am I doing lately?
Right, and occasionally somebody would sabotage it and say like, oh, Dion grows tulips in his forehead. Right. And then someone else would fix it. Oh, he doesn't grow tulips in his forehead. Yeah. And it was a great little game, but now it's no longer there. But the Proteus phenomenon, according to Wikipedia, is related to the winner's curse. And the winner's curse has to do with auctioneering. So if you go to an auction, you tend to overpay always. Yeah. And the reason you overpay, well, why do you overpay?
Because you're not talking about the inherent value of what you're auctioning. It's a competition. It's a bidding war.
There it is, right.
You want to beat someone.
The more bidders there are, the more...
And you have a limit, right? You say, I'm only going to go this far. This has happened to me. And you hit that limit, and then the other person outbids you. And then you're like, well, I can go over that limit a little bit. And then you go over it. And then you psychologically keep on raising it.
That's the psychology of the winner's curse. But there's statistics around the winner's curse as well, having to do with the economics of game theory. On average, everyone will overvalue the item. So all it takes is one person in the realm of bidders to overvalue it more than the average, and suddenly the average overvaluing goes up.
The anchor bid.
Exactly.
Yeah. Okay.
Right. So how does that relate to the Proteus phenomenon? Well, if the bidders are all the publications, then on average, people tend to overvalue the quality of the size.
Yes. Okay. That makes sense. They have a form of silent auction where they start at the Dutch tulip markets.
It's always
like
the
this.
Dutch.
The
tulips,
Dutch do this.
More with tulips.
It's just a clock. The clock starts out at a very high price. It's much more. And then it starts going down. And everyone has a button. And the first person to stop the clock gets it at that price.
Oh, wow.
That's a lot of pressure too, right? Because you're like, oh, I got to press it now. Anyway, I wonder, it'd be interesting to see which one produces higher bids.
Well, we talked about validity. Why don't we switch to the celestial emporium of benevolent knowledge?
We have an acronym for that? CEBK. Doesn't work. But we have music for it, right?
Yeah. Start the music now.
Okay. So we were talking about validity. And there's an excellent Taoist text. You talk about Taoism, everyone knows the Lao Tzu or the Tao Te Ching, the way in its power.
Well,
Duh, yeah. Actually, that was good. Duh. And there are many different translations of it and so forth. In fact, I've heard the Lao Tzu is the second most translated book after the Bible. It's pretty incredible. But that's not my favorite Taoist text. My favorite is the Zhuangzi, which is usually spelled Chuangtzu. That's the old Wei Giles system. In pinyin, it would be Z-H-U-A-N-G.
The Wei Giles system?
Wei Giles, yeah.
Wasn't that a band, the Wei Giles Band?
No, that's
Freeze
right.
frame. No?
The Wade and Giles were two missionaries, English missionaries, who came up with a romanization system for Chinese, which was based on ancient Greek romanization. It doesn't make any sense. So that's why they spell Z as T-Z-U and Zhuang as C-H-U-A-N-G. Oh, by the way, just an aside here. The Japanese word for Japan is either Nihon or Nippon. Doesn't sound anything like Japan. So you may ask, where do we get the English word Japan from?
Where do we get the English word from Japan
I'm
from?
glad you asked. It was the Chinese the Chinese characters for Japan are日本in Chinese, and using the Wei Giles system, when you want to transliterate that into English, it turns out to be Jihpen. And then if you don't know how to read Wei Giles, rather than saying Urban, when you see that, you'll say Japan, and that became Japan. So it's through the Japanese name being spelled in spelled in Chinese, and then translated in English, and then.
Wow! Did you hear that, listener? God disapproves of our podcast.
Take it all back. The Zhuangzi. And that's my dog. Ooey.
Oh, I look so scared. Come here, Louie.
Aw.
Come here. It's okay. It's okay.
Coming in with his high heels on.
okay.
Click, 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 click. It's just some lightning. Just some lightning. You can stay with us.
Yeah.
Lie down right here. Yes, lie down right here. So, talking about validity, the second chapter of the Zhuangzi is called A Discussion on Making Things Equal. It's a really good chapter. You can go online if you Google. We'll have a link to the text is online. He says, suppose you and I have had an argument. If you have beaten me instead of my beating you, then are you necessarily right and am I necessarily wrong? If I have beaten you instead of your beating me, then am I necessarily right and are you necessarily wrong? Is one of us right and the other wrong? Are both of us right or are both of us wrong? If you and I don't know the answer, then other people are bound to be even more in the dark. Whom shall we get to decide what is right? Shall we get someone who agrees with you to decide? But if he already agrees with you, how can he decide fairly? Shall we get someone who agrees with me? But if he already agrees with me, how can he decide? Shall we get someone who disagrees with both of us? But if he already disagrees with both of us, how can he decide? Shall we get someone who agrees with both of us? But if he already agrees with both of us, how can he decide? Obviously then, neither you, nor I, nor anyone else can decide for each other. Shall we wait for still another person? But waiting for one shifting voice to pass judgment on another is the same as waiting for none of them. Harmonize them all with heavenly equality. Leave them to their endless changes, and so live out your years. What do I mean by harmonizing them with the heavenly equality? Right is not right, so is not so. If right were really right, it would differ so clearly from not right that there would be no need for argument. If so were really so, it would differ so clearly from not so that there would be no need for argument. Forget the years, forget distinctions, leap into the boundless, and make it your home.
That's deep, man.
Very useful. So what if half of the scientific studies are false?
All right, so let's. We have time for some facts and furious.
Oh, yeah. That lightning was pretty dramatic. This is a either or. Are there more atoms in a grain of sand, or are there more grains of sand in the entire Earth?
Oh, I think there are more atoms in the grain of sand.
You're right. That's correct. Okay. I've got to check this out. Where do horses breathe through?
Oh, boy. We're talking anatomically?
Yes.
Oh, I don't know.
Metaphorically?
Your inner eye.
Horse chakra. This is your whiskey, right?
Oh, thank you.
Yeah.
Horses breathe through, their nostrils?
Exclusively, apparently. They
Oh,
can't
look
breathe
at
through
that.
their mouths.
Oh.
Yeah, so excellent. What kills more people? All illegal drugs combined or alcohol?
Oh, alcohol, easily.
Yes, that's correct.
He says while sipping his whiskey.
That's right. Yeah, we have the wrath of God to
We have time for
confirm
one
that.
more question, I believe.
One more?
Sure.
What was Ralph Lauren's real name? This is hardly scientific.
Raphael Lubenstein or something?
Ralph Lifshitz.
Oh, that's even better. Hashtag science, my friends.
I love that a guy named Ralph Lifshitz makes like the quintessential waspy wardrobe.
All right, well, on that note, this is Monkey Ray and
Monkey Graham.
saying oop oop.
An eagle's mate while airborne.